All right, welcome everyone to another deep dive. We're tackling another really fascinating area of AI today.
Yeah, it seems like every week there's a new breakthrough to wrap our heads around.
Absolutely. And today we're focusing specifically on, you've probably seen the title Generative AI Agents.
That's right. We've been going through some pretty dense material. These excerpts from a paper simply titled Agents. It's from February 2025.
So yeah, we'll try to make this, as straightforward as possible. We're kind of on a mission here to just really distill these key concepts down.
Exactly. We want to figure out what an agent is, what it's made of, how it works, and probably most importantly, how you can potentially use them, for cool projects, maybe even a winning Kaggle submission.
Yeah, absolutely. So I think a good way to start is just, think about it like this. Just like we use tools, right? Like books, search engines, we use those to kind of make ourselves smarter, more effective.
Right. AI models are starting to do the same kind of thing, but in the digital world.
Exactly. So let's start with the basics. What is a generative AI agent?
So an agent in this context is essentially a program that goes beyond what a standalone generative AI model can do. It adds in reasoning, logic, and crucially, access to information outside of just its own internal knowledge.
So it's not just creating text or images, it's actually trying to achieve a specific goal.
Yeah, exactly.
Yeah.
And it does that by kind of observing the world around it and then taking actions based on what it sees, using whatever tools it has available to it.
So it can be given a goal and then operate pretty much independently.
Exactly. And it can even figure out the steps it needs to take to reach that goal, even if you haven't told it exactly what to do at every step.
That's pretty powerful stuff. Now, the paper does specify that it's focusing on agents that are built using generative AI models. What kind of scope are we talking about here?
Yeah, so the focus is specifically on agents where the core decision making, the intelligence of the agent, is coming from these advanced language models.
So the language model is the brain of the operation.
Precisely.
Got it. Now, to really get how these agents work, we need to look at what the paper calls their cognitive architecture. It's kind of like their internal operating system, right?
Yeah, it's the set of components that determine how the agent behaves, how it makes decisions, and how it actually takes action.
And looking at figure one in the paper, we can see that this architecture is broken down into three main parts.
Right,
The first one is the model.
right. So the model here refers to the language model itself.
Mhm.
This is the heart of the agent's intelligence. It's making the decisions. It could be one language model, or it could even be a bunch of models working together.
And the paper mentions they could be different sizes or have different specializations.
Exactly. And what's really important is that these models need to be able to use these instruction-based reasoning and logic frameworks,
Mhm.
things like React, chain of thought, tree of thoughts. These are frameworks that help the model think through problems strategically.
The paper also mentions that these models could be general purpose or multimodal or even fine-tuned for specific tasks. What's the benefit of that kind of flexibility?
Well, it means you can choose a model that's, whose strengths really align well with what your agent needs to do. Like if your agent is going to be interacting with a particular API a lot, it's best to use a model that's been trained on data that's similar to, how that API is used in the real world.
So you're saying the model would perform better if it's already encountered data that reflects how that API is typically used.
Right. But it's also important to note that the model isn't usually pre-trained with like specific agent configurations. So it doesn't inherently know which tools it's going to be using or how the whole orchestration layer is set up.
Okay, but the paper does say that you can fine-tune it, right?
Yeah, exactly. You can give it examples of how the agent should use the tools and reason through things, and that can help it learn.
All right, so we've got the brain, the model. The second part of the architecture is the tools.
Right. And this is where agents get really powerful. They can actually do things in the world because on their own, those foundational models, they can generate text and images, but they can't interact directly with like the physical world or even with other digital systems.
So tools give them the ability to reach beyond their initial training data and actually affect things.
Exactly. And there's a huge variety of tools. Some are simple, some are really complex, but a lot of them, they kind of map to how web APIs work. Like getting information, creating new data, modifying data, deleting data.
So, like if an agent needs to update a customer record or fetch some data from a website, it would use a tool for that.
Exactly.
Yeah.
And, this ability to work with external systems, that's really key for things like retrieval augmented generation or RA.
We'll definitely come back to that later.
Sure.
Yeah.
But the key takeaway here is that tools are what allow agents to connect their internal reasoning with the outside world. That's what opens up all these possibilities.
All right, so we've got the brain, the model, we've got the hands, the tools. What's the third piece of the puzzle? The orchestration layer.
Right. So the orchestration layer, this is like the control center of the agent. It's the process that manages how the agent takes in information, how it reasons about that information,
Hmm.
and then how it uses that reasoning to decide what to do next. And this process, it keeps going, it cycles through these steps until the agent reaches its goal.
So it's making sure the model and the tools are working together smoothly and effectively.
Yeah, exactly. And, the way this orchestration happens, it can be pretty simple or it can get really complex. It might involve a series of calculations or more involved logic, maybe even using other machine learning algorithms.
So there's a lot of flexibility in how the agent can be controlled.
Absolutely.
Okay, so we've got a good understanding of what makes up an agent: the model, the tools, and the orchestration layer. The paper also spends some time contrasting agents with just the models themselves.
Right. And this is important because it highlights why agents are so much more powerful.
Yeah, I mean, at first glance, it might seem like an agent is just a model with some extra tools attached.
Yeah, but it's way more than that.
So, what are some of the key differences the paper highlights?
Okay, so the first big difference is knowledge. A standalone model, its knowledge is limited to what it was trained on. But an agent, because it has access to tools, it can keep learning. It can access up-to-date information from the outside world.
So, it's not limited by its initial training data?
Right. The second big difference is about how they handle information over time. A model typically makes a single prediction based on the input you give it. It doesn't really remember past interactions.
But an agent can.
Yeah, agents are designed to keep track of what's happened before, the whole history of the interaction.
Hmm.
So you can have multi-turn conversations with an agent, and it will remember what you've talked about before.
Okay, that makes sense. What else?
So the third key difference is that models don't have like built-in support for tools. Tools are an essential part of an agent's architecture. And then finally, while you can use clever prompt engineering to guide a model's output, models don't have a dedicated logic layer. But agents do. They have this cognitive architecture that we talked about, which can directly incorporate these reasoning frameworks like React or chain of thought.
So, it's not just about having the tools, it's about having the built-in intelligence to use those tools strategically.
Exactly.
All right, let's move on to the next section where the paper really digs into how these agents operate. It's the section on cognitive architectures.
Right. And they actually use this pretty interesting analogy here. They compare an agent to a chef in a busy kitchen.
A chef.
Yeah, so think about it. A chef doesn't just throw ingredients together randomly. They follow a process, they get the order, they see what ingredients they have, then they think about what dishes they can make, they chop, mix, cook, and they constantly adjust based on what's happening.
So it's this constant cycle of planning, acting, observing, and then refining their approach.
Exactly, and that's pretty much how agents work too. Their cognitive architectures allow them to do this whole process of taking in information, reasoning about it, making decisions, taking actions, and then learning from the results.
And at the heart of this whole process is the orchestration layer.
Right. That layer is responsible for keeping track of everything that's happened, the current state of the task, and then managing the reasoning and planning.
The paper also mentions that prompt engineering plays a big role here.
Absolutely. Prompt engineering, it's all about crafting those really effective instructions for language models. And that's crucial for guiding the agent's thought process.
Okay, so let's talk about some of those specific frameworks that the paper highlights for guiding this reasoning and planning. The first one is REACT. What does that stand for again?
REACT stands for reason and act. It's this framework where you encourage the language model to think step by step, to reason, and then to interact with the environment. Using tools, that's the act part, based on what the user is asking.
So it's not just about getting a final answer. It's about showing the user how the agent got there.
Right. So it might start by thinking about what needs to be done, then try something out, maybe use a tool, see what happens, and then keep reasoning based on that result.
That sounds like it would lead to more reliable answers as well.
Yeah, because you can see the agent's thought process, so it's more transparent and trustworthy. Then there's chain of thought, or COT.
Right, COTI. What's the idea behind that?
So chain of thought It's all about getting the model to think through a problem in a very structured way, like writing out a series of logical steps that lead to the solution. Instead of just asking for the answer directly, you guide the model to explain its thought process step by step.
It's like showing your work in a math problem.
Exactly. And there are actually several variations of CoE that the paper mentions, like self-consistency, active prompt, and multimodal CoT.
So different flavors of CoT for different tasks.
Right. And then there's tree of thoughts, or TOTI.
CoT.
Yeah. This one is, it's kind of like CoT on steroids. It's designed for problems where you need to explore lots of different possibilities to be more strategic.
So instead of just a single chain of thought, it's like branching out, exploring multiple paths.
Yeah, exactly. Like imagine you're playing chess. You don't just consider one move at a time. You think about different sequences of moves. You try to anticipate your opponent's responses. That's kind of what TOTI is doing.
That's a really interesting way to think about it. Now, the paper also gives a really good example of how React works in practice, like a step-by-step breakdown of the process. Can you walk us through that?
Sure. So imagine a user asks the agent a question. Let's say they want to book a flight. The agent, following the React framework, will prompt the model to generate the next step. It might start by asking a clarifying question, like, where are you flying from?
Okay, so it's clarifying the user's request.
Right. Then it might have a thought, where it considers the best way to find the flight information. Maybe it decides to use a flight API. So then it takes an action. It calls the API.
So it's interacting with an external tool to get the information it needs.
Yeah. And then it gets the results back from the API, and that's the observation. Based on that, it might reason some more and decide to ask the user about their preferred travel dates. And this whole cycle can repeat several times, with the agent asking questions, thinking things through, using tools, and refining its understanding until it finally has all the information it needs to actually book the flight.
So it's like a back and forth conversation between the agent and the user, with the agent using tools and reasoning to gradually gather all the necessary information.
Exactly. And figure 2 in the paper actually shows this whole sequence visually, which can be really helpful to see.
Yeah, figures are always good. And of course, how good the agent's final answer is, whether it can actually book that flight correctly, that depends on how well the model can reason and how effectively it can use the tools it has available.
Right.
Which brings us to our next big topic, tools, our keys to the outside world. Now, we've talked about tools a bit already, but I think it's worth reiterating, just how crucial they are.
Definitely. I mean, language models are great at processing information and generating text, but they can't actually do things in the real world on their own.
Right, like they can't control a robot arm or buy something online.
Yeah. So tools are what bridge that gap. They connect the model to the outside world, to external systems and data sources, and that's what allows them to do all these amazing things.
And the paper focuses specifically on the tools that are available for Google models, right?
Right. And it breaks them down into 3 main categories: extensions, functions, and data stores.
Okay, so let's start with extensions. What are those all about?
So extensions are essentially a standardized way to connect an agent to an API. They make it real easy for the agent to use the API without having to worry about all the low-level details of how that API actually works.
Okay, so like if I was building an agent to help people plan trips and I wanted to use the Google Flights API, an extension would make that a lot easier.
Exactly. Because without an extension, you'd have to write a bunch of custom code to, like, interpret the user's requests, figure out the right API calls to make, handle all the errors that could pop up.
Sounds messy.
Yeah, it can get pretty complicated. But with extensions, it's much more streamlined. It's like, you give the agent some examples of how the API should be used, and it kind of learns from those examples.
So the agent figures out how to use the API just by seeing some examples.
Yeah, exactly. And, the great thing about extensions is that they're developed independently, but then they're included in the agent's configuration. So at runtime, the agent can actually look at the user's query and choose the most appropriate extension based on those built-in examples.
So it's dynamic. It adapts to the situation.
Right.
And Google provides some pre-built extensions that we can just use, right? Like that code interpreter example in snippet 1.
Yeah, the code interpreter, that one's really cool. It basically lets the agent generate and execute Python code.
Wow. So I could ask it to write a function to sort a list or something and it would just do it.
Exactly.
That's awesome. Okay, so extensions are all about giving agents a standardized way to use APIs. What about functions? How are they different?
So functions are kind of like functions in regular programming. They're self-contained pieces of code that do a specific thing. But in the agent world, the language model decides when to use each function, and it figures out what arguments to give it based on the function specification.
And the paper highlights a couple of key differences between functions and extensions. First, with functions, the model doesn't actually make the API call itself.
Right. It just decides which function to use and what data to give it.
And second, functions are executed on the client side, meaning on the user's device or whatever is interacting with the agent, whereas extensions run on the agent side.
Exactly. So going back to our flight booking example, with functions, neither the agent nor the function itself would directly talk to the Google Flights API. Instead, that API call would be made by the user's app or whatever system is interacting with the agent.
And that gives the developer more control, right? Because they can handle the API call however they need to on their own system.
Yeah, exactly. And there are a bunch of reasons why you might want to use functions instead of extensions, like maybe the API requires some kind of authentication that the agent doesn't have.
Or maybe you need to process the API response in a specific way before sending it back to the agent.
Yeah, or maybe you're still developing the agent and you don't have the actual API set up yet, so you just want to simulate the API calls for testing.
That travel concierge example in the paper really illustrates how powerful functions can be. Where the agent suggests cities for a ski trip, but it doesn't directly interact with the Google Places API.
Right. The agent just generates the names of the cities and sends them to the client-side application. And then the application can use those suggestions to fetch images and other information from the Google Places API.
So it's like the agent is delegating that task to the client-side app.
Yeah, exactly. And the paper shows in Figure 9 a sequence diagram of this whole process.
Yeah.
It's pretty clear how the model is just filling in the blanks, providing the information that the client-side UI needs to make the API call.
It's a really clever way to split up the work and give the developer more flexibility.
Yeah, absolutely. And there are some other cool uses for functions that the paper mentions too, like suggesting functions to the user without revealing any sensitive credentials. And you can also use functions for things that need to happen asynchronously.
So a lot of power and flexibility there. And snippets 6 and 7 actually provide a concrete example of how to define a function in Python and then use it with the Gemini 2.0/001 model.
Yeah, it's a nice, concise example that shows how you can build a tool based on a function and then have the model use it to answer a query.
Okay, so we've covered extensions and functions. The last category of tools is data stores. Now, the paper uses this analogy of a language model's training data being like a giant library of books.
Right, but the problem with a library is that the books are static. They don't get updated.
So if the world changes, the library's knowledge is out of date.
Exactly, and that's where data stores come in. They give agents access to information that's dynamic, up-to-date, and relevant to the current context.
So instead of being limited to the information it was trained on, the agent can access external data sources like databases or APIs to get the most current information.
Precisely. And it's not just about getting the latest news or stock prices. It can be any kind of information that's relevant to the agent's task. Like if I have a bunch of internal company documents or maybe some research papers that I want the agent to be aware of, I can use a data store to make that information accessible to the agent.
And I don't have to retrain the model or anything.
No, the data store handles all of that. It takes those documents, it converts them into a format that the agent can understand, and then the agent can query the data store to get the information it needs.
And the paper specifically mentions vector databases being used for this.
Yeah, because vector databases are really good at storing and searching through this kind of information. They can represent the meaning of text and other data in a way that makes it easy for the agent to find what it's looking for.
And one of the most powerful applications of data stores is retrieval augmented generation, or array.
Right, RA. And that's a technique where you essentially give the language model access to a huge external knowledge base.
So, instead of relying solely on its internal memory, it can actually search through a massive amount of data to find the most relevant information to answer a query.
Exactly. And this external knowledge base, it can be anything. Web pages, PDFs, spreadsheets, you name it. Figure 12 in the paper actually shows how a single agent can be connected to multiple data stores at the same time.
That's pretty impressive.
Yeah, it's really powerful. And Figure 13 shows the typical workflow for a RAG-based system. It starts with the user's query, which is converted into a vector embedding. Then that embedding is used to search through the data store to find the most relevant documents. Those documents are then sent back to the agent, along with the original query, and the agent uses all of that information to generate a response.
So it's combining its own internal knowledge with all of this external information to give the best possible answer.
Precisely.
Now, the paper has a nice tools recap table that summarizes the key features of each tool type. What are the most important things to remember about each one?
Okay, so the table highlights where each tool is executed and what it's best used for. Extensions and data stores, those are executed on the agent side within its infrastructure. Function calling, on the other hand, happens on the client side. Now, extensions are great for when you want the agent to directly control how it interacts with an API, especially when there are pre-built extensions available or when you need to make multiple API calls in sequence. Function calling is better when you have security concerns or authentication issues, or when you need more fine-grained control over when and how the API calls are made. And finally, data stores are essential for implementing RG, which is all about giving the agent access to a wide range of external data sources.
That table's a great reference. Now, one of the biggest challenges with these agents is making sure that the model chooses the right tool for the job, especially as these systems get more complex. So the paper talks about some ways to enhance model performance with targeted learning, and they bring back that cooking analogy again.
Yeah, because just like a chef needs to know more than just the basics of cooking, language models often need some specialized knowledge to be truly effective at using tools.
So how do we give them that knowledge?
The paper outlines three main approaches: in-context learning, retrieval-based in-context learning, and fine-tuning-based learning.
All right, let's break those down.
So with in-context learning, think of it like this. You give the chef, which is the model, a specific recipe, which is the prompt. You give them the necessary ingredients, which are the relevant tools, and maybe you even show them a few examples of what the finished dish should look like.
So it's learning from the specific information that's provided right there in the prompt.
Exactly. And then there's retrieval-based in-context learning. This is like giving the chef access to a huge pantry full of ingredients and a whole library of cookbooks.
So they have a wider range of knowledge to draw from.
Right. And when they get a new recipe, they can search through the pantry and the cookbooks to find the most relevant information and techniques. This is similar to how RAG works and how the example store feature in Vertex AI extensions can be used.
So it's like augmenting the model's knowledge with this external database of information and examples.
Exactly. And then finally, we have fine-tuning-based learning. This is where you actually send the chef back to culinary school to specialize in a particular type of cuisine.
So they're getting more in-depth training in a specific area.
Right. It's like taking a model that's already pretty good and then training it on a huge data set of examples that are very specific to the types of tasks and tools that you want it to use.
So you're essentially teaching the model to be an expert in using certain tools or in a particular domain.
Exactly. And of course, each of these approaches has its own trade-offs. In-context learning is fast, but it might not be as effective for really complex tasks. Fine-tuning can be really powerful, but it takes more time and resources.
Makes sense. But the good news is you can often combine these techniques to get the best of all worlds.
Absolutely.
Now, for those of us who are eager to start building our own agents, the paper has a really cool section on Agent Quick Start with LangChain.
Yeah, this is where they show you how to build a simple but functional agent using these open source libraries, LangChain and LangGraph.
LangChain. I've heard of that.
Yeah, it's a really popular framework for building these kinds of agents. And the example in the paper uses the Gemini 2.0/001 model, along with a couple of simple tools, one for searching Google and one for getting information from the Google Places API.
And they use all of this to answer a pretty interesting question, right?
Yeah, so the question is, who did the Texas Longhorns play in their last game, and what's the address of the stadium? So it's a multi-step question. You need to first figure out who they played, and then you need to find the address of the stadium.
And the code in Snippet 8 shows how to do all of that with LangChain.
Exactly. It shows how to set up the API keys, define the tools, initialize the model, and then create a React agent that can answer this multi-part question.
And Snippet 9 shows the actual output of the agent, which is pretty cool to see. You can see how it first searches for the opponent, and then it uses that information to find the stadium address.
Yeah, even though it's a simple example, it shows all the core pieces working together: the model, the orchestration layer, and the tools.
Now, for those who are thinking bigger, building production-level applications with these agents, the paper also touches on using Vertex AI agents.
Right, because when you're building something for the real world, you need a lot more than just the basic agent logic. You need things like user interfaces, ways to evaluate how well the agent is performing, and systems for continuously improving it.
And Vertex AI provides all of that.
Yeah, it's a fully managed platform from Google that has everything you need to build, deploy, and manage these sophisticated agent applications.
Mm.
And it has this really nice natural language interface where you can define what you want the agent to do, what tools it should use, and you can even give it examples of how it should behave.
So you don't have to be a coding wizard to use it.
Exactly. And figure 15 in the paper actually shows a sample agent architecture built on Vertex AI. It's a great overview of how all the pieces fit together.
It's impressive how much functionality they've packed into that platform.
Yeah, it really simplifies the whole process of building and deploying these agents.
All right, we've covered a lot of ground here. Let's quickly recap the main takeaways about generative AI agents.
Okay, so the big picture is that agents are a major step forward from just using language models on their own. They take those powerful models and give them the ability to access real-time information, to interact with the world, and to plan and execute complex tasks. And often they do this by using multiple language models working together.
And the key to making all of this work is the orchestration layer.
Right. That layer uses cognitive architectures and these really cool reasoning techniques like React, chain of thought, and tree of thoughts to structure the agent's thinking and guide its actions.
And then we have the tools themselves, which are absolutely essential for connecting the agent to the outside world.
Exactly. We talked about extensions for working with APIs, functions for more controlled client-side execution, and data stores for giving agents access to vast amounts of external data, especially for argan.
The future of agents looks incredibly exciting. More sophisticated tools are being developed all the time, reasoning capabilities are improving, and we're going to see more and more of this agent chaining where different agents with specialized skills are combined to solve really complex problems.
Absolutely. And it's important to remember that building these agents is an iterative process. You experiment, you learn, you refine your approach. There's no one-size-fits-all solution.
But the foundational concepts that we've discussed, they provide a really solid framework for getting started and building truly innovative applications.
Yeah, and just to quickly summarize the tools one last time, extensions, remember, those are for making API calls directly from the agent. Often there are pre-built extensions available, which makes things a lot easier. Functions, those are for when you need more control, when you want the execution to happen on the client side. And data stores, those are key for implementing argan and giving your agent access to lots of external data.
Now, for all of you amazing Kaggle folks out there, especially those of you working on your capstone projects, think about how you can use these concepts and these tools to build something truly innovative. What kind of agent could you create? What problems could you solve? Which tools would be the best fit for your project?
Yeah, get creative. Think about how you can combine different tools, different agents, different reasoning frameworks to create something completely new. This is really just the beginning of what's possible with generative AI agents.
Absolutely. And for those who want to learn more, definitely check out the full white paper and the resources we've mentioned, like the LangChain documentation and the Vertex AI documentation. There's a ton of great information out there.
Thanks for joining us for this deep dive. It's been fun exploring this with you.
Until next time.
See ya.